Okay, we're going to start with a warm-up. So on your powers chart, you have certain numbers. So if I said 2 to the x is equal to 32, this becomes an exponential equation. It's an equation that you're solving for x, and because the x is in the exponent, we call it an exponential equation. Your job is to figure out what that exponent is. And on your powers chart, you would look and you'd go, oh, I know this one. The answer is x is equal to 5. And so if I gave you other ones that are on your powers chart, 3 to the x equals 27. This is why you need to have your powers chart memorized and the mental math ready to go. You can say, oh, I know that. 3 cubed is 27, so we can go x is equal to 3. Now, in this unit, we're eventually going to get to the point where we say, I know that 3 cubed is 27, but what happens if it was equal to 30? What would the answer be? Well, more than 3, because 3 cubed is 27, but less than 4, because 3 to the 4 is 81, but how do I do that? Right? And what happens and what we do in math is over time we develop sort of strategies, sort of mathematics, like 2x plus 1 equals 7. What would you do with this? You have strategies. You subtract 1. Why? So you get that? What is that helpful? Divide by 2. Right? You had a system. You had a system to undo something. Right? And you got x equals 3. You could have probably guessed and checked and figured out that it was 3. Right? Right? And got x equals 3. But this is nice because if I change this to 112x plus 1 equals 7, there's probably not a lot of guessing and checking that you could do that would work well here. But this system, 112 equals 6, what would your answer be? 6 divided by 112. And you could type that in your calculator and tell me exactly what the decimal is and be like, I can solve that. Okay? And we have different things. But right now in this unit, we're eventually going to learn some math to solve that. But at this moment, all we have is our powers chart and the ability to recognize things. And we're going to use that at the beginning because all of our non-calculator questions will be recognizing things on our powers chart. So in question A, we have 4 to the x equals 1 over 256. And our strategy is to use our power chart. So here we go. Strategy 1. We're going to use our powers chart. Whoa. To change both sides to a power with the same base. Okay? Because if I went back to here and gave you another question, when we had 3 to the x equals 27, some of you just saw that it was 3. But if I had written the 27 as 3 cubed, does it become even more obvious that the answer is 3? I mean, the exponent on this side is the x. The exponent on this side is the 3. What could x possibly be? And so if I gave you another question, 7 to the x is equal to 7 to the 301. What do you think x is? 301. Because these would have to be the same if they're equal. So this is going to be our strategy. If we can make both sides to the same base, we can too make the exponents the same, or equate the exponents. Now this is going to require that we know our powers chart and we know our exponent laws. So the first thing in this question, we see a 4 and we see a 256. The question is, are those numbers in the same column on your powers chart anywhere? Which column? In the 4. What is 256? It is 4 to the power of 4. So at this point, I have, and I'm able to change 256 to 4 to the power of 4. Now we haven't quite changed both sides to a power with the same base. This has a base of 4, but here the 4 is in our denominator. What exponent rule could I use on the right-hand side to write this as 4 to something? 4 to the power of negative 4. Your negative exponent rule moves something from a denominator to a numerator or vice versa. Taking notes on your phone? Okay, good. And now what's x? Negative 4. Because at this point, we can say, all right, my bases are the same, so my exponents have to be the same, and x is equal to negative 4. So for all of these questions, our job is to think about mental math, our powers chart. How can we recognize numbers? Where are they the same? You're going to need to use your exponent laws to make your bases the same, and then you can equate your exponents. So let's look at part B. It's a little bit more advanced. (27 to the x) equals 9 to the 2x minus 1. On your powers chart, do you have a power that you could change? Yes, they're both powers of 3. So what we do is instead of 27, we would write 3 cubed. How do I deal with that x? Well, anytime you're substituting something else for something else, it's good to put it in brackets. So the 27, there would still be an x there. Can you see that that's equal to what we had before? And same thing on this side. I'm going to replace the 9 with 3 squared, and there would still be a 2x minus 1 here. Now our exponent rules come into play. How do you do a power to a power? You multiply. Okay? So with your exponent rules, again, that's going back to grade 9. Grade 9 mental math, exponents and stuff. But we have to not only know them and understand them, we have to know them well, so when we get into situations like this, when we're dealing with algebra and variables, we remember, when do we add exponents? When do we multiply exponents? Do I understand why, so I won't get those rules mixed up when I'm dealing with new situations? So here, we would multiply. Okay? And I feel like I want to rehash the reasons why we do these things, so I'll do that with some simple numbers once we're done here. An exponent to exponent here, we multiply. How do you multiply when you have 2 times 2x minus 1? You have to distribute. You get 4x minus 2. We have now done step 1. We changed both sides to a power with the same base. We now know that our exponents are the same. So I like to write 3x would have to equal 4x minus 2. How would you solve this? Combine your like terms, move my x's to this side, move my 2 to this side. Oh, there it is. X is equal to 2. exponent rules are easy to memorize, in my opinion, because they're easy to understand. As far as understanding exponent rules, and it's been since grade 9, so chances are, when you're in grade 12, you have much more enhanced brains, you have a greater ability to understand things than maybe when you were back in grade 9. Most likely your grade 9 teacher taught you how to understand the exponent rules, but sometimes when you're in grade 9, you're not ready for that, or you just didn't pay attention and didn't care, and now are reaping the benefits of that in grade 12. So, what is an exponent? If I have 5 cubed, what does that mean? It means 5 times 5 times 5. That's what an exponent means. It means repeated multiplication. This helps us understand some exponent rules. When I have 5 squared times 5 to the 5, I guess I'll make that number. What's the rule? The rule says you need to add. If you forgot why that rule is there, just think about what exponents mean. 5 squared is 5 times 5. And 5 to the 5 is 5 times 5 times 5 times 5 times 5. How many 5s do you have all multiplied together? 7 of them. Does the rule that says you need to add make sense? Okay? Now, if you just memorize the rule, you would hear your teacher saying crazy things. You'd go home and say, our teacher is crazy, grade 9 math doesn't make sense. Why is that? Well, we're learning in class that when you multiply, you add. Did your teachers ever say just that sentence? Probably. Does it make sense? No, when you multiply, you multiply. What is this crazy stuff? When you multiply, you add. That's like not right math. What do you do when you divide? No, you divide. But yeah, but you learned that, right? When you divide, you subtract. It seems like crazy math. Right? They're weird rules. When you multiply, you add. No. When you divide, you subtract. They're like they don't make sense when you just look at the words. You okay? But if you think about why they work, okay? So if I have 3 squared cubed, this is the one that we just used. We needed to multiply. This is equal to 3 to the 6. Why is that? Well, this would mean I have 3 squared 3 times. That's what the cubed on the outside means. And the 3 squared means 3 times 3, 3 times 3, 3 times 3, 3 to the 6. And all of a sudden you see I have 3 groups of 2, which is multiplying. It makes sense that I would multiply there. So if you think about what an exponent means, the rules will make sense to you. But now we're applying those rules with algebra. So if you don't know your rules and you haven't made sense of them enough that you've got them memorized, here we have to be able to apply them with algebraic stuff. So we really have to make sure we know them. So we equate our bases so that, we write both sides with the same base, and then we can say, therefore, the exponents would have to be equal, and solve from there. Okay, try questions 3, 4, 5, and 6.